Mamma mia, salut les amis et bienvenue dans cette nouvelle vidéo. Welcome to this new video. Today we are going to solve another exercise under circuit analysis, circuit exam for ITC and ATC, page 1. I have already sent the question to you. Here the first question is to find the voltage across the resistor R4. Here we have two methods in order to get that voltage across that resistor. We can first of all evaluate the voltage at this point. Let's say we have here a point. Let me take the pen. Let's say we have here a point A, maybe here a point B, and here let's say the point M, which is the reference according to the ground. The first thing that we are going to do is to evaluate the voltage between A and M, and then use voltage divider and get the voltage across R4. Otherwise, the second point is to use to first of all evaluate the total current flowing through the circuit, get this current which is going down here as well as this current which is going there. At the end, use Ohm's law in order to get that voltage across R4. So here you have several methods. Some person can use either Millman and so what, and you can. But here I'm going to use but Ohm law. Means that the first thing that I'm going to do is to evaluate the current, total current flowing through the circuit here, which is called, let's say, I. Means that the first thing that I'm going to do is to evaluate the equivalent resistor of this circuit. So I'm going to represent something like this. The equivalent circuit, let's say we have a battery source like that. Okay, this is R equivalent. You can discover that the current which is flowing here will be equal to the supply voltage here, which is 50 volt, which is 50 volt divided by R equivalent. Here the question here is to find the R equivalent. According to this circuit, you discover that the R equivalent here is R3 plus R4, all in parallel with R2 plus R1 in series. So that equivalent resistor will be equal to R3 plus R4, all in parallel with R2, all in series now with R1. So we can simply write like this: R3 plus R2 is going to give 30 plus 20 is giving 40 ohms, parallel R2 here is 50 ohms plus R1, which is 25 ohms. And to get this, we are going to have the equivalent resistance of this one is 1 ohm. When you have two resistance in parallel with the same value, is equal to that equivalent resistor divided by 2. Means that the equivalent resistance by this 50 ohms, two resistance of 50 ohm will give off only 25 ohms. So somebody else can write 1 on 50 plus 1 on 50 plus 25 ohms. It means that this one will give you 25 plus 25, which is equal to 50 ohms. Means that the equivalent resistance here, means that the R equivalent here, R equivalent is equal to 50 ohms. That is it. Once you have obtained that equivalent resistance, we are going down and evaluate that total current. The total current here, according to that this diagram up, the current will be equal to I is equal to 50 volt divided by 50 ohms, which is equal to 1 amps. Means that the current flowing up there, I is equal to 1 amp. Once you have obtained that 1 amps, that current, means that the current which is flowing here is equal to 1 amps, and that current reached at this junction A divided into 2. So we are going to evaluate the current which is going now in, let's say, first of all we are going to evaluate the voltage at point M. The voltage at point M, according to Ohm's law, is equal to the voltage at the higher potential means that that thing is looking voltage across that resistor is the voltage at the higher potential minus the voltage at lower potential will be equal to the current flowing through that resistance multiplied by that resistor. So I'm going to write V at the higher potential means that 50 volt minus VA will be equal to I, the main current that we have already found, multiplied by R1. Once you obtain it like this, we can say that the unknown point here is this item, means that VA alone will be equal to 50 volt minus I times R1. So when you apply this, I is equal to 1 ohm and R is equal to 50 ohms. When you apply this, you discover that VA will be equal to 50 volt minus I here was 1 ohm times resistance, which was 25 ohms. When you apply this, it's going to give you 50 volt minus 25 volt, which is equal to 25 volt. Means that VA will be equal to 25 volt. That is it. So we have already evaluated that voltage at point A, means that VA equal to 25 volt. Let me write properly. 25 volt. Once you have obtained that voltage, you can use maybe voltage divider in order and get VR4. Let's say we are going to use voltage divider. VR4 is equal to R4 multiplied by the supply voltage, which is here VA M divided by the sum of the total resistor. Otherwise, you can still use but Ohm's law. Once you have obtained that VA, which is equal to 25 volt, we can say the current flowing through R2, the current which is going down here, is equal to VA minus VM divided by R2. I don't want to wipe because we are going to use all. Means that the current I2, let's say the current which is going inside resistor I2 is equal to VA minus VM divided by R2, which is equal to VA is equal to 25 volt minus VM 0 volt, because it's the reference of the voltages, divided by R2. Let's say I'm going to look the value of R2, 50 ohms, divided by 50 ohms. When you apply this, it will give you 0.5 amps. That is that current flowing through the resistor R2. Something wrong? Okay, that is that current flowing through the resistor R2. Means that the current flowing through the resistor R2 here is equal to 0.5 ohms. Let's say we are going to write that current 0.5 ohms, 5 ohms. And that current going out, the current flowing through resistor R4, you can use but the first law of Kirchhoff. We say that the total current entering the junction should be equal to the total current leaving the junction, and that current going through R4 will be equal to the main current minus that 0.5 ohms, 0.5 amps. So we can simply write total current going inside the junction is here is I, will be equal to I2 plus I flowing through I4. Means that I4 that I'm looking for alone will be equal to I4 will be equal to I, the main current here, which is 1 amp minus 0.5 amps, and that thing will give you 0.5 amps. Means that the current flowing here through this point is 0.5 amps. Now, according to Ohm's law, we discover that the voltage across that resistor R4, V R4 will be equal to current time resistor R4, and you have current which is equal to 0.5. that current is equal to 0.5 times R4, means that voltage V R4 will be equal to I 0.5 amps times 20 ohms. When you multiply this, you're going to give you 10 volt. Means that voltage, the voltage across R4, V R4, let me wipe in order to get a small space, V I4 will be equal to 10 volt. That is all. If you have a question, don't forget to ask in the description section below. Let us go ahead now and solve for the second exercise. For the second exercise, you have some transformation to do. Because we have this T, delta to T. I'm going to transform that star to delta. I'm going to transform this circuit in order to get, let's say, a resistor here, another here, and another here. And this resistor, let's say here is RA, RB, and here RC. And you know all the process in order to get that all those value of resistor. I was supposed to draw another diagram so that it should be very simple for me to carry out that thing. Let me take it over again. Let me take it over again and go down here. Okay. Okay, that is it here. I've already pasted it very well. I was saying that the first thing here is to transform this circuit, this star diagram, into delta. And here you can see here is RA, here is RB, and here RC. Okay, you have a junction here. Here, according to what we saw in the last class, we said that to transform this star to delta, RA here will be equal to R here. This value of resistor should be equal to this one plus this one plus this time this divided by this other one. So I'm going to have RA is equal to 5 plus 10 plus 5 times 10 divided by 20. This will give us 15 plus 50 divided by 20. 50 divided by 20. You can cancel like this, and then you will remain 2.5. Means that RA will be equal to 17.5 ohms. Now RB will be equal to this plus this times this divided by this, which is equal to 10 plus 20 plus 10 times 20 divided by 5, which is equal to 30 plus 200 divided by 5. 200 divided by 5 will give off 40, and that 40 plus 30 will give off 70. Means that RB is equal to 70 ohms. Most of the time when you get an answer like that, it's normal to square it. Okay, let us go ahead and evaluate RC. Means that RC alone, RC will be equal to RC is equal to 5 plus 20. 5 plus 20 plus 5 times 20 divided by 10. When you apply this, RC will give us 35 ohms. 35 ohms. Okay, that is it now. Once you have obtained this like this, now it will be very simple for us now to find the equivalent resistance of this circuit. So we can simply write without any matter, saying that we have a voltage source there, we have the first resistor, we have the second one, which is RA, reaching this junction, divided like this, and here you have another one, RC, again reaching this junction. That is that, and that other external resistor, which is 30 ohms. That is it here. And here is RA. Here is RC, and here is RB, and the last one at the output will be 30 ohms. Now it will be very simple for us now to get the equivalent resistor. We discover that the equivalent resistor here will be equal to this parallel this plus this parallel this, all item in parallel. So we can simply say that R equivalent is equal to this item and this item in parallel, which is equal to 1 on 12.5. okay, sorry 1 divided by 1 12.5 plus 1 on RA was 70.5 plus in series this other item here is 15 parallel RC, and RC is equal to 70 plus, let me write it down again, R equivalent is equal to 1 on 12.5 plus 1 on 70.5 plus in series 1 on 15 and RC, and RC is equal to 70. Now all in parallel, because this item series all in parallel with RB as and 30 ohms, RB and RB here. No, RC is equal to 35. Yes, yeah, means that I'm going to wipe this 35. All this item in parallel with 70 ohms, and in parallel with the external resistance was 30 ohms. 30 ohm. 30. Okay, we are going to open the calculator and evaluate this item. I don't have the calculator with me, but we are going to see how we can manage this. Let me put it into scientific calculator. Mamma mia, this thing will not be longer be simple to evaluate. Anyway, we are going to use all the steps here, this item plus this item. So I can simply write here is 12.5 times 70.5 divided by 12.5 plus 70.5 plus 15 times 35 divided by 15 plus 35, all in parallel with 70 parallel with 30. Okay, let me first of all evaluate this. 12, let's see, 12.5 times 70.5, it give off 280. This sound is with this one kings. This sound is with one kings divided by, when you add this one down, is given to you, give us 0.1230 remaining 1 2 3. That is it. Now plus 15 times 35, here I'm going to open the calculator. Here is 0 remaining 1 3 4 5. 15 times 35, 15 times 35, 525. Now all in parallel with 70 30. Okay, when you have this now, let us finish at once. 217.75 divided by 33, 65. Let's say punch it into 6.6, 6.6. That will give us 6.598. Now the other one, 5525 divided by 50 will give off 10.5 plus 10.5. Now in parallel 70 parallel 30. Now when you add these two items plus 6.598 70.1, let's say 17.1 parallel 50 parallel 30. Let me change the pen so that okay, when you reach here now, the equivalent resistor for these three elements in parallel is very simple to find. R equivalent here will be equal to 1 on 17.1 plus 1 on 70 plus 1 on 30. I don't know how to use this negative on. Okay, that is correct. Now let me say cancel this 70.5.1. okay, inverse plus 70 inverse plus 30 inverse, we give off 0.110. now inverse again, we give me 9.425, 9.425, means that equivalent resistor will be equal to equal to 9. That's all. It took much time, but at the end we reach the final answer. So once you have that equivalent resistor like this, means that from this circuit we have this equivalent resistor which is 9.425 ohm, all in parallel with this voltage source of 120, with a voltage of 120, means that we can draw the equivalent circuit like this. We can draw an equivalent circuit like this. You have a voltage source of 120 volt, and you have an equivalent resistor of Req, so that we can simply get the current flowing here. If you launch a small mesh inside this circuit, you discover that the current I will be equal to voltage source 120 volt divided by R equivalent, and R equivalent here is 9.425 ohms. Now when you apply that formula, let's open the calculator. Divided by 120 equal to N1 on X, then you give off 12.73 amps. 12.73 amps means that current I is equal to 12.73 amps. It's too big, but anyway, if you have a question, if you have solved it in your own way, just put your own answer in the description section below, because I was not using the scientific calculator. Okay, means that current is equal to 12.73 amps. And that the current flowing here, IT is equal to 12.73 amps. Let me record that current but up, so that it will show us very well. I is equal to 12.73 amps. Okay, now let us move now to the last question number 3. In that last question number 3, I'm going to copy that figure again, so that we will have enough space to make a calculation, much calculation. Control C, let's see here, Control V. We are now here in this question. You discover that from this circuit we have a Thevenin source in series with a Norton source. First thing that we can do is to transform this Norton source into Thevenin source, as well as you can still transform this Thevenin source into Norton source in order to get the main current flowing through the circuit, and then apply Ohm's law and get the voltage across R2. So there's no way to do. The first thing that I'm going to do is to transform this current source, this Norton source, into Thevenin source. Let's say I'm going to quickly redraw the circuit. I have something, this resistor like this voltage source, and the direction is up, and there I have a voltage source. And the direction is showing there, and here and the output resistor is there, R3 equal to 10 ohms, and here this voltage source is equal to R2 time, means that this voltage source here will be equal to 2 amps times 8 ohms. Is 2 times 8, means that 2 times 4 ohms, it means that it will give you 8 volt, and this resistor should be remain R2 equal to 4 ohms, and this voltage here is 64 volt, and this other one R1 is still the same, 8 ohms. Once you have obtained it like this, you discover that you have two voltage source in series. We are going to find the equivalent voltage source. Let's say we are going to redraw another circuit, so we are going to have that resistor will remain, and we get the equivalent voltage source there, and that resistance will be there. And here is still R3 equal to 10 ohms, here R2 equal to 4 ohms, and here R1 equal to 8 ohm, and here this voltage source is the sum of the two voltage sources, is the sum of this one plus this one, means that 64 plus 8 volt you give us 72 volt. Okay, once you have obtained it like this, it will be now very easier to find the current flowing through this circuit, and the current flowing through that circuit is the voltage source divided by the sum of resistor, means that that current will be equal to the voltage source 72 volt divided by the sum of resistor, means that 8 ohms plus 4 ohms plus 10 ohms. When you apply this, means that I here will be equal to 72 volt divided by, when you make 12 plus 8 plus 4, it will give us 12 plus 10, it will give us 22 ohms. Okay, let us go ahead again. Means that current I will be equal to 72 volt divided by 22 ohms. Let us open the calculator and get that answer. Let me first of all wipe this. 72 divided by 22, yes, you give off 3.27 amps, which is equal to 3.27 amps. 27 amps. That is the total current which is flowing through this circuit. Means that the current which is flowing here is equal to all the circuit. The total current delivered by the voltage source is equal to 3.27 amps. Once you have obtained that current, according to this diagram, the voltage across that R2 will be equal to the voltage at the higher potential minus the voltage at the minor potential will be equal to current I times the resistor R2. Means that VR2 will be equal to I, the main current flowing through the circuit, multiplied by R2. When you apply this, means that VR2 will be equal to I, who was 3.27. Let me take it over again. 3.27 multiplied by 4 ohms. 3.27 multiplied by R2 was 4 ohms. When you apply this according to Ohm's law, it's going to give us 13.909 volt. This is the voltage VR2. If you have another way to solve this circuit, you can simply propose in the description section below. Another way to get this voltage VR2 is to use voltage divider, because you discover that the voltage across R2 will be the part of this main voltage. Means that we can say that the voltage across R2 will be equal to R2 multiplied by 72 volt divided by the sum of the resistor, which is 8 plus 4 plus 10. Let's see. VR2 will be equal to 4 ohms multiplied by 72 volt divided by 4 plus 8 plus 10. When you apply this, let us open the calculator and see what we can get. No. 4 times 72 equal to 200 divided by 22. There's a mistake somewhere. There is a mistake somewhere. Let me look whether I have not make a mistake. 8 ohms for 10 ohms. I is equal to. Anyway, you are going to check it with the voltage divider and see where the mistake is coming from. The mistake is coming from 4 times 72 4 times 72 200 and divided by 820 divided by 22. Okay, that is it. I did not apply it very well. Then you give off 30.09. This will give us 13.09 volt. This is another way in order to get that voltage across R2. 13.09 is 09, not 04. Okay, if you have the question, don't forget to ask in the description section below. I hope you have covered all the part of this exercise. Okay. That is it all. We have covered all the part. If you have the question, don't forget to ask in the description section below. Switching guide for watching. Don't forget to subscribe. Have a nice day. Peace.